is finding the roots of x to the fourth minus 2x cubed plus 5x squared minus 6 equals 0 in the interval 1, 2. Okay. It says use Newton's method to approximate the indicated root of the equation correct to 6 decimal places. So remember, what this is doing is it's taking a graph, you pick a point, it goes up to the point on the graph, draws a tangent, comes back down to the x-axis. Do you remember the visual of this or not? Where the tangent crosses the x, go up again, comes back. That's right. And you just repeat that until you keep getting closer to the true x-intercept. So this equation has an answer between 1 and 2. How do we know that it has an answer between 1 and 2? I mean, how do I know that? Plug in 1. What do you get if you plug 1 in right now? 1 minus 2 plus... Why does my freaking computer keep doing that? Plus 5 minus 6, which is what? Negative 2? Is that right? Okay. Now plug in 2. What's 2 to the 4th power? 16 minus, let's see, 2 cubed is 8 times 2, so minus 16 again, plus, let's see, 2 squared 4, 20, and then minus 6, this is 14. So how do I know that I have a solution to that equation between 1 and 2? Drum roll. How do I know between 1 and 2 this graph, this equation has a solution? There you go, Elias. That's it. Because at 1, if I were to look at the left side of this as a function, right? If I treat this as a function, then if I plug in 1, I get negative 2. And if I plug in 2, I get 14. So my graph must go from the blue, connect the blue points. And it has to be continuous, right? Meaning I can't pick up my pencil. Why? Is that a continuous function? X to the 4th minus 2x cubed plus... Yes, it's a polynomial, right? So I've got to connect these without picking up my pencil. So I have to go through 0, don't I? So there's somewhere in there that I pass through 0. I can't tell you where it is. But using Newton's method, we can approximate it. We can get real close. Okay, so Elias's question was, what point do you pick? And I say pick one of the endpoints. Let's try 2. So that means I'm going to let my x0, my x0, be 2. Now what was the formula for Newton's method? X sub n plus 1 equals x sub n minus f of x sub n over f prime x sub n, right? Isn't that what it was? That means that if I try and get my next point, x sub 1, it will be x sub 0 minus f of x sub 0 over f prime x sub 0. So I would like to find the derivative before I continue doing anything else. If my original function is x to the 4th minus 2x cubed plus 5x squared minus 6, then the derivative of this is 4x cubed minus 6x squared plus 10x, and that's it. So we get to plug in, we're going to plug in 2 to start, right? So I'm continuing here, right here, I'm continuing with this, plugging in 2. So 2 minus f of 2 over f prime of 2, which is 2 minus, now f of 2, didn't we do that a second ago? It was 14. Over Now plug 2 into the derivative. 2 cubed is 8, 32. 32 minus 24 plus 20, 28. Hey, isn't that exactly 2.5? Oh wait, not 2.5, 1.5. Agreed? That's exactly 1.5. So that's x sub 1. Now, what's x sub 2? It's x sub 1 minus f of x sub 1 over f prime x sub 1, which is 1.5 minus f of 1.5 over f prime of 1.5. This is just tedious now, right? But as far as difficulty level, would you agree it's not so bad? I mean, it's just plug and chug. Elias, have I addressed your question?
Yeah.
Like, where do you start, right? Okay. They always gave you that initial, yeah. And you know what? When you ask a calculator to solve something like this, it just does a guess. It just starts somewhere. It just guesses. And then if it doesn't converge within a few tries, it tries something else. All right, I want to see what this turns out to be. So let me, it's 1.5 minus, hold on. I'm waiting for my calculator to do something here. Come on, man. So I'm getting on the top, bless you, negative 18.9375 over 15. Is that right? Oh, no, it's not. I typed something in wrong. My apologies. The numerator, I think, is wrong. I'm not going to go through another step of this. This is the last step I'm going to do. Every time you do another iteration of this, your number should get closer and closer to something. It shouldn't be jumping all over the place. So let's see. If I plug in 1.5 into the original function, I get 3.5625. Anyone else get that? Okay. And did you get 15 into the derivative? Yeah. So what did you get for the answer? 1.26 for everything? Okay. And then you go again. And what the book is saying is that do it until you're correct to 6 decimal places. What would that mean? 6 decimal places. You keep going until I'm just going to make this up, but maybe the next time we do this, it's 1.2, what? Is that what it is? Oh, no. It won't necessarily do that every time, though. That's not the way it converges because it's not a linear type relationship. So let's say the next one you get 1.6254. Then the next time 1.26231. The next time 1.26234. You know what I'm saying? Like 1.26230. Let's say this was 47. 43. No. At some point, they want it correct to 6 decimal places, right? So they want the 6th decimal place. 1, 2, 3, 4, 5, 6. You see in the next line, those 6 didn't change. that's when you can stop. That's a tolerance, right? So the further you go, the more times you keep doing this, you can get it correct to more and more decimal places. So the Newton's method allows you to be as accurate as you want to be. And that's, like I said, that's what your computer does. It says, okay, once I keep doing this, and in the 15th decimal place, it stops changing, I'll stop. And I'll send that answer to the user. I'm not going to ask you for this many iterations on the test. Yeah, I'll just say when you're correct to like 2 decimal places, 3 decimal places. Yeah, it's not going to be like repeat 8 times, 10 times. You don't remember what you... How you started at 1.5? So you just picked a point. Oh, I don't know. I just picked an endpoint. Yep, I picked 2. Yep, yeah, and that was Eliza's initial question. It's like, what do you start with? I picked 2. You could have been 1.5, or you could have picked 1. Yep, that's right. What you don't want happening is this, though. Let's say our first time through we got 1.5, and the next time we got 2.3. And the next time we got negative 2.7. Then the next time 4.2. When you start getting that, there's issues. Because Newton's method will converge to an answer if your initial picking of your point is good enough. But we don't talk about what that is. We don't really get into that. Because you can just... you can take a function like, let me see, a good example might be something that's like a sine function like this. And maybe you're trying to find this x-intercept right here. So what you do is you pick an initial point over here, right? So that tangent sends you down here. That gives you this point. You go to the function here, and now that tangent sends you back over here. You go over here like this. That sends you back... That sends you back over here, right? Then you pick this point, and now it's going to give you a tangent that's going to send you over here. You see how those tangents keep sending me all over the frickin' place? Right? So it's not a perfect method unless your first guess is good enough. That's right, I didn't. That's why the book does. Because they know if you pick anything between 1 and 2, it's going to converge. Just sometimes it might take a little longer than others. See, like if I cut this off, let's say I were to take this same picture and I just cut off in here and I force you to pick a point in here. Now if I pick this, it's going to go and hit here, right? Then I go there, it's going to hit somewhere in here and then back up and then back down and back in, and it's going to start smashing into the 0. I hope that makes sense. Okay. Alrighty. That won't happen. I won't give you that. It's always going to give you, what's that? But it says start by drawing a graph to find initial approximations. So what they would want you to do is like go to a graphing calculator and graph the function and then say, it looks like it's close to 3, so I'll pick 3.5 or something like that. But they don't want you just randomly, just out of the blue, grab a point. All right, I'm gonna talk about 4.7 and chapter 5 a little bit. Today is not going to be this is not going to be real structured because we're kind of at the end of the course. This is kind of where we start to transition into Cal 2. All right. So I want to do a real quick kind of recap of what Cal 1 has been about, right? What did we start Cal 1 with? Can you nudge him real quick?